It is a pleasure to welcome you to the pitch sharing session of the third edition of the lecture series on advancements in geotechnical engineering, from research to practice. At the pitch sharing session we asked the participants to explain their research with 3 slides and within 5 minutes. They were judged by a 4-member judging panel and the audience members. The pitches that were adjudged as top 3 by the judges and audience members are being shared. The following presentation was from the winner of the pitch sharing session adjudged by the judging panel.
Hello everyone, my name is Shaivan Shivaprakash. I'm a second year PhD student at Georgia Tech. My advisor is Dr. Susan Burns. I'm also affiliated with the CPPG. Well, today I'm going to give a brief presentation on my research focus, that is MICP, but extended to carbonate-rich soils and construction waste. Well, the first question is, what is MICP? Essentially, it is the precipitation of calcite crystals facilitated by microbes. So how does it occur? The first step is the urea hydrolysis. Microbes have the urease enzyme, which hydrolyzes urea and results in the production of ammonia. The increase in the production of ammonia results in an increase in pH of the system. The high pH then favors calcite precipitation. So my research is, the objective of my research is to extend the domain of MICP to carbonate-rich soil and construction waste. I'll briefly talk about my initial results that I've obtained. So we have performed column experiments and we have found that MICP is 2 to 3 times more, at least 2 to 3 times more effective in carbonate-rich soil and construction waste. If you observe closely at this figure, this turquoise line, you can consider this as to be a baseline, Ottawa 2030 sand. And then these 2 blue lines, these are the results from the carbonate-rich soil. We have done both biostimulation and bioaugmentation. So clearly we can see that there is at least 2 to 3 times increase in carbonate precipitation, calcite precipitation. And this line over here, this huge increase in calcite, this is with respect to construction waste. But we can also see that halfway down the column, it decreases rapidly. We suspect that clogging phenomenon is much more evident in the construction waste sample. Also, because the sample has some kind of a calcium hydroxide mineral, we think that there may be some dissolution as well going on. And here is an SEM micrograph of the construction waste sample, which has been treated. And you can see the big, beautiful blocky structure of calcite crystals. And this is an SEM image of stimulated carbonate-rich soil with the microbes shown in green color. Okay, so what is the significance of our research? Why did we choose carbonate-rich soil and construction waste? Well, in 2021, the UN IPCC climate report was released, and they indicated that there is a likely increase in global mean sea level of 0.4 meters by 2050. If we observe this figure, all the models almost predict the same amount by 0.4 meters. So what does that mean? That means our coastal cities and shorelines are under threat and they need to be protected. However, these shorelines and coastal zones are typically rich in carbonate deposits, and hence we thought it is necessary to investigate whether we could apply MICP to such soils and what contribution the research could have in this direction. The other thing is, of course, the construction waste. EPA, the Environmental Protection Agency, estimated about 600 million tons of construction debris generated in the US in 2018. This is usually discarded as waste, but we believe that they are economically viable for beneficial use. And to finally conclude with broader impacts, well, when we think about MICP in our research group, we think of what MICP could be. It could be a cost-effective, or rather, we want it to be a cost-effective and sustainable ground improvement technique. If we look at the 2 images below, especially that of Singapore, Singapore is inarguably one of the most developed cities in the world. They have adopted a biophilic design for their city. The people are much happier. The city is much more greener. And then you have this sort of a sustainable infused urban development. And this building on the right side, this is the Candida building here at Georgia Tech. This is the most green building in the Southeast United States. This building has a net positive energy, which means it basically gives more energy than it consumes. And it is a beacon of sustainability here on our campus. These two, I guess, are sort of examples that comes to my mind. And I would like to conclude by saying that that's what we think of our research as to be, as our research making a means, or rather a contribution to making a better and more sustainable world. Thank you.